All right, so to wrap up 4.7, we're going to see how the trig functions and their inverses sort of work together. So if you remember from section 1.8, when we talked about inverse functions, we said that f of f inverse of x should equal x, and the other way around. So for example, let me see here. This right here would be an example of f inverse of x equals x. And then this would be an example of f inverse of f of x equals x. Now, the only thing that you have to watch is that, remember, these trig functions, in order to make them one-to-one, we had to restrict their domains. So, for example, the sine of x, we had to restrict its domain to negative pi over 2 to pi over 2. So as long as x is a number between negative pi over 2 and pi over 2, that's very, very simple. It'll just come out to be that same number. But if it's something outside that interval, that's when you need to be careful. Okay. All right, continuing with section 4.7, I'm redoing this part of the video in my office. It was a little glitchy when we did it in class, and I made some improvements to the slides. So thinking back to the last slide that we looked at in the last part of section 4.7, it talked about how using the inverse properties of the trig functions, you have to be a little bit careful with domain issues, basically. So when you see something like this, the inverse sine of the sine of pi over 3, what you're asking yourself is, what is an angle? Because remember, an inverse trig function is an angle. What is an angle that has the same sign as pi over 3? And remember that this angle has to be in the interval between negative pi over 2 and pi over 2. Well, the good news is pi over 3 is already between pi over 2, negative pi over 2 and pi over 2. So this one is sort of the easiest kind you can get. The inverse sine of the sine of pi over 3 is just pi over 3. So what are some of the things that can happen that are not that simple? Well, here's one I cooked up. The inverse tangent of the tangent of 9 pi over 10. So I thought it would be helpful to have a picture of the angle 9 pi over 10. I tried to find one on Google Images and I couldn't find one. So I went ahead and made this one. Try to overlook that it's being labeled in degrees. That was the only way I could figure out how to do it. So 9 pi over 10 is in quadrant 2. And this again is the inverse tangent again would be a mystery angle just for variety. I think I'll call this one alpha. So the angle alpha will have the same tangent as 9 pi over 10. But the trick is that this angle also has to be between negative pi over 2 and pi over 2. So in other words, it can't be in quadrant 2. So what we have to think about is what is an angle in that interval that has the same tangent as 9 pi over 10. That angle is going to have the same reference angle as 9 pi over 10. So the reference angle for 9 pi over 10 is pi over 10, isn't it? Because you would do pi minus 9 pi over 10. So that would be 10 pi over 10 minus 9 pi over 10. So your first thought might be, oh, okay, well, I'll just use pi over 10. But that's not going to work because remember, all students take calculus. In quadrant 1, the tangent is positive, and in quadrant 2, the tangent is negative. So that means we have to go down here to quadrant 4, all right? So we're looking for the angle in quadrant 4 that has that same reference angle, pi over 10. And then the other thing you have to remember is it's going to be a negative angle because for the inverse tangent function, we have to use an angle between negative pi over 2 and pi over 2. So that angle is going to be negative pi over 10. Okay. So yeah, that kind of problem's a little bit tricky. You just have to be careful that you're putting your angle in the correct interval. So remember, for sine and tangent, it's going to be between negative pi over 2 and pi over 2. For cosine, it's going to be between 0 and pi. So actually, if this problem had said the inverse cosine of the cosine of 9 pi over 10, 9 pi over 10 would have worked as an answer for that. Okay. And then there's one other kind of problem that comes up in this section, and these are actually a little easier. When you see the trig function on the outside and the inverse trig function on the inside, what this is asking is, what is the cosine of an angle whose cosine is 0.7? All right, let me say that again. What is the cosine of an angle? Because remember, this thing right here is an angle. What is the cosine of an angle whose cosine is 0.7? All right. Well, that is much less complicated than what we were just talking about. That cosine would be 0.7. Okay. So the only way they can trip you up with this kind of problem with the trig function on the outside is to use a value that is not in the domain of the inverse trig function. So if I word this one the same way, what is the cosine of an angle whose cosine is negative 1.2? Well, remember that the range of the cosine function, just like the range of the sine function, is between -1 and 1. So this value right here is undefined. All right, there is no angle whose cosine is -1.2. So if you see something like this, the answer is undefined.